이제 이번 동영상은 Sleep Line Field Analysis로 일명 SLF에 대한 강의를 시작하도록 하겠습니다. 이것은 특히 절삭 가공에 많이 원용이 되는 이론이 되겠습니다. There are planes of maximum shear which are oriented at the 45 degree to the axis of principal stresses. 주축에 대해서 45도로 방향을 갖는 최대 전달 능력 평면이 있는데 maximum and minimum slim lines are orthogonal. 서로 maximum slim line, minimum slim line 서로 직교한다. 특히 요 부분을 우리 다음 제 나름대로 증명을 해 보이겠습니다. Slim line field SLF theory is based on analysis of a deformation field that is both geometrically self-consistent and statically admissible. Slimline field SLF analysis, a graphical approach, depends upon the determination of fluid flow pattern in metal forming. 금속 성형에 있어서 플로우 패턴, 소승 흐름 형태를 결정해 주는데 이 SLF analysis가 유용하게 쓰인다. Slimline field solutions provide valuable insights into the nature of material flow in cutting process and the effect of friction at the grain workpiece interface. Oxley used the experimental flow fields to model an appropriate slimline field. Experimental flow fields were obtained from magnified motion fixtures of grease on the side of a chip, side flow being prevented by a glass plate attached to the side of the workpiece. An experiment-based SLF was then altered until boundary conditions, velocity, and force were satisfied. 그림 1을 보세요. 그리고 이게 이제 SLF 그림을 보여주고 있는데. A computer were used to construct the slimline fields consistent with experimental flow fields. Initially, modeling was for low cutting speeds, where the effect of a strain rate and a temperature on flow stress could be ignored. Later, strain hardening and the strain rate effects were introduced that gave more realistic results for higher cutting speeds. User assumptions: the matter is isotropic and homogeneous. The matter is rigid, perfectly plastic. This implies the neglect of elastic strains and treats the flow stress as constant. Deformation is by plane strain. Possible effects of a temperature, strain rate, and the time are not considered. There is constant shear stress at the interfacial boundary. Usually either a frictionless condition or sticking friction is assumed. The general methodology of SLF analysis can be described by the following steps. First, differential equations in terms of mean strength and the deviatory stress for plane strain deformation are formulated. SLF is constructed graphically out of orthogonal maximum and minimum shear lines. From known stress at some point, the integral constants are determined. From this, the cutting load can be found. The basis for SLF analysis is the fact that general state of stress on a solid in plane strain deformation can be represented by the sum of two types of stresses, namely the mean stress and the pure shear stress. 이 정도 입문을 하고 본격적인 얘기는 다음 동영상에 보여드리도록 하겠습니다. 감사합니다.